Let's give them a round of applause. Okay, so restrooms, we know where they are. If you're a PCA and you're just arriving, there's incremental credit for each of the different sessions. You just need to go to the registration at the entrance there, and they'll allow you to get credit as a QAL, QAC, or PCA. This whole event has been made possible thanks to not only the City of Gonzales, but also Ramsey Highlander and Hudson Martin Witten June. They were our sponsors, and a number of other partners. This next section is genetics and crop protection. We have two doctors in the house that are helping to revolutionize our industry. Dr. Hank Hill has been a great partner in this, as he's kind of been my main man, helping to round up great help from our friends at Monsanto Vegetable Seeds, and that's Dr. Bill Waycott. So they're going to be talking about genetics and crop protection. And like I said, then we have lunch. Hopefully everybody does know that there is a drawing for a flat screen television. All you need to do is fill out the passport. Anybody can do it, need not be present to win. Just get signatures from each of the vendors, and yeah, and then we'll be good to go. What do you guys think? Are we about there? Just got to bring it up.
I have to launch it.
Okay, he's launching it, so it's coming. I'll just say a word or two about Converted Organics. Some of you might wonder where you're at. They've been here about 10 years. This is a 13-acre campus where fish off of the Monterey Bay, really the waste from the fish processing industry, along with food waste from Greenfield High Cafeteria, Salinas at Costco, and Red Lobster, is combined with byproduct of the corn processing industry, put into an aerobic digester, and out the other side comes a number of different fertilizers used in both conventional and organic farming. The idea is soil health, promotes healthy crops, right? Lots of available nutrients. It's kind of an exciting topic that'll play into our 1 p.m. panel. So that's our host. I will point out that there's these demonstration beds out here. There is a Hartnell College intern that's been working tediously on monitoring what goes into the beds, the response, and what looks like an outbreak, a recent outbreak of aphids. So you can ask Armando about his test beds. There's also a similar test going on at Salinas High School as well. Really, really exciting. And we'll get here in just a second. I will mention some of our other partners, obviously the Farm Bureau, the Chamber of Commerce for Salinas Valley, City of Gonzales, of course, FFA, both at Gonzales, and Soledad's in the house as well, and Salinas High. City of Salinas, City of Gonzales, it's good stuff. What about there, buddy? He's working on it. There might be a question, sure. And we do have the media present, so it's probably worth acknowledging. You know, Dennis Taylor's been with the Salinas, California a long time, and he's the ag reporter. So if you've got a really cool ag story, he's the guy to talk to. He's always looking for fun leads. We're glad you're here. Yeah.
Yeah, you're talking about the converted organics, but I've also heard like they do a horse farm in the Pescadero and Half Moon Bay that's taking this a step further, where they're not just growing fish underground in tubs, but they're also growing plants on top in beds that are partly immersed into the water, so they actually grow vegetables on top.
On top of aquaculture.
That's the model that's being looked at.
It's funny you say that. I think your question was, look at some of these operations where aquaculture and farming are kind of one and the same. And I own a retail nursery in Salinas. It's called McShane's Nursery, and we actually are selling now a unit that's portable, and it's under $100. That's an aquarium with an herb farm on top. So we had a demo unit. So far, so good. But I just, I'm thinking, I've had fish before, and sometimes some things can go wrong. I think it takes more than a PCA to manage something like that. But I'll tell you, I think as we look to our first speaker, some of you heard John Harnett, he talked about the future of agriculture. I think we better be prepared for, systems like that, where, it's not just protein, but, protein alongside your vegetables, kind of in a system. So it's very, very fascinating. Yeah. Okay. I want to thank Jorge here. He's with Blue River Technology. So thank you very much. I think we're about there. He's going to blast through this because we don't want to keep you from lunch too long. We got about 40 minutes or so, 45 minutes. So please help me in welcoming from Seed Dynamics, Dr. Hank Hill. We'll do our best.
Okay, anyway, my name is Hank Hill. I'm the seed physiologist for Seed Dynamics. And with me joining on the podium today is Dr. Bill Waycott from Monsanto Vegetable Seeds. I'm going to be talking about new advances in seed technology and crop protection, and Bill is going to be talking about the genetics, new genetics for crop protection in lettuce. Anyway, the definition of a seed treatment, if you can see it up here, is any product or process that can improve the value of the seed lot. That's a pretty simple definition. And what our company does is we do not sell or buy seed, we treat seed. We make your seed better. And we have several types of seed treatments that we're going to be talking about today. Let me just give you a quick rundown. Our company was started in 1985 with 5 employees. Right now, 29 years later, we have 60 plus employees. And we are the largest processor of lettuce seed in California. Our 2 major competitors process about just 70% of what we do. Okay, the important thing about seed treatments is, and our company is, we apply seed treatments so that growers can obtain the most optimal stand possible, and this stand has got to be uniform. Okay? And I said before, we lead in lettuce seed technology. We process more lettuce seed than our 2 major competitors combined. As time allows, I'd like to talk about seed coatings. And the reason why I'd like to talk about seed coatings is that seed coatings is the history. But you have to understand the history before we move on to the future. And the future, of course, right now, as far as we're concerned about in seed treatments, is new systemic chemicals that can protect the seed for up to 30 days. Okay? And what the idea is, you put the chemical on the seed so you don't put it in the environment. Okay? This way we use a lot less chemical. The chemical is systemic and it is absorbed by the plant over time, and you can have protection against microorganisms and insects for up to 30 days right now, but they're working on it so that we could get full crop protection. The interesting thing about this is that during the summertime, a lettuce crop is about 60 days. So using these new type of systemic chemicals, you're going to have protection for half of the crop growing season before you have to do any other spraying. I'm sure that as time goes on, that with microencapsulation, this type of protection may last throughout the whole growing season of the plant. And I hate to put the CPAs out of business, but maybe we won't see many more spray rooms. A coated seed, by definition, and I have to kind of go through with this, is any seed that has been filmed, encrusted, mini-coated, or pelleted. And if you can see from this photograph, these are onion seeds. The seeds on the far left are the raw, the middle seeds are film-coated, and the seeds on the far right are pelleted. Please notice that the pelleting changes the size and the shape of the seed. Okay? And the reason why changing the size and the shape of the seed is important is it allows it to be mechanically planted. And this is where we all started from. Seed Dynamics, of course, we have all sorts of different coated seed pellet sizes for different types of planting equipment. And the same case with the onion. This is a picture of raw lettuce seed versus coated lettuce seed. Notice that the raw lettuce seed looks like a flat fish. How are you going to mechanically plant something like that? Okay? But if you coat the seed, you have a nice round globe to work with, and of course that's easily transplanted with modern equipment that they have now. This is a picture of the modern equipment. This is a Stanhay planter. Stanhay planters first came into use in 1974 in this country. They were originally developed in England. Okay, here's the interesting thing about the Stanhay planter, is that for its time, it had a revolutionary planting shoe, so that you had better depth control, and also because it was belt-driven, you can singulate the seed so that you can have different spaces between each seed drop. And this is still the system that we use today. Because the Stanhay planter had an advanced planting system, you could get better depth control. And the interesting thing about depth control and lettuce is that if you plant all the seeds at the same depth, they're all going to come up nearly the same time, and you'll have better uniformity. Because if you're just talking about a 60-day crop, better uniformity at emergence, of course, translates to better uniformity at harvest. But it wasn't the goodness of our heart that made us want to develop pelleting technology. We had social issues involved. And these social issues was over the short-handled hoe that was outlawed in 1974. Prior to the outlaw of the short-handled hoe, seed was planted using solid seeders, and you had to go into this break-backing work to hand thin the plants down to 1 plant per foot. Our friends from Blue River are even going to take away what we do now. Oh yeah, let me say that there was a lot of lettuce to thin. And because the lettuce could be singulated now, we could use a long-handled hoe. Our friends at Blue River want to take away this tedious job as well. So I hope you can understand that over time, there is a progression in technology, although sometimes it doesn't quite happen as fast as we'd like. Okay, so now we have the pellet. And we use the pellet, of course, to automate planting technology. What else can we do with this pellet that might advance agricultural technology? And the idea, of course, is that we can use this pellet as a carrier of pesticides. You're going to use a lot less pesticides, and it's right there on that target organism, the seed. And it can be easily absorbed by the root system as the seedling develops. This first picture is a picture of onion smut. I know that we don't grow a lot of onions in Monterey County, but I bring up the lesson of smut for a reason. I hope that you can see from this chart that the Thiram and Carboxin and Manab down there, that bottom line, you have 1,042 grams of active ingredient per acre to protect your crop. With tetrabutaconazole, you can say that 5 times fast. With tetrabutaconazole, you have reduced the 1,000 grams of active ingredient per acre down to 2.5. And so you can apply a lot less fungicide on a per acre basis if you apply the fungicide. If you apply the fungicide directly to this. This is another problem with onions. This is onion maggot. Now, I know that we don't have problems with onion maggot here in the valley, but on muck soils, there is a problem with onion maggots. And they can be very devastating. This chart is a little complicated, but I'd like to bring up the same lesson that we talked about with the fungicides. Notice that the percent infected seed with no treatment, we have 74% infected plants, but we have all of these different insecticides that can be applied directly to the seed. And notice that with TriGuard, Entrust, and Suppresto, this is the new generation of systemic insecticides that you get a real reduction in the percent of infected seedlings. Lorsban is down at the bottom. That is one of those mean organophosphates that have caused so many problems in the past. Notice that the effectiveness of the Lorsban isn't as good as the new systemic pesticides. The other thing I'd like to call your attention to is one of these systemic pesticides, Entrust, is known by the trade name of spinosad. This is an organic insecticide, and notice that it's extremely effective in the suppression of leaf gnat.
Excuse me. Are the TriGuard, Entrust, and Suppresto, are those coated seeds?
No, those are chemicals that we put on the coated seed.
Right. So okay, they're part of the process.
Yeah. What you can do, and we're not the only ones to do that, but what you can do is once you have the seed coated, you can put on the pesticide. And if the pesticide is a little hot, that is, if there's some sort of phytotoxicity issues, the seed itself is a little bit removed from the application of the pesticide so that you don't get as much seedling damage. Suppresso is a neonicotinoid. We're going to be talking about that in just a few minutes. There's several neonicotinoids. Let me just get back to the onion treatment here. Notice that as compared to the old in-furrow treatment of Lorsban, you're using just 10% of the chemical that you used to use before. So this is where the industry is heading. Okay, they're developing new systemic chemicals that will allow the plant to be well protected over time, and less chemicals are sprayed out into the environment. This is a little slide on the neonicotinoids. I know that this has been in the news quite a bit because of the association with honeybee problems. The idea is if you put these neonicotinoids on the seed and not release it into the environment, then there's less exposure to beneficial insects. The other interesting thing about the neonicotinoids, even though they do suppress honeybee populations, is that they have plant growth regulator effects. This is some data coming out of Geneva, New York. I hope you can see that the line of green beans on the left grow better than the non-treated green beans. Is this because of the suppression of the potato leaf hopper, or is this because there was a plant growth regulator effect and you got better crop growth? This is a famous picture of some soybeans in Brazil. In Brazil they spray Cruiser even if there is no insect problem because you get better plant growth. And you can see on the left of the picture that the soybean crop has better height and better leaf area coverage than the plants on the right.